Okay, here we go. There are 6 sum and difference formulas that you need to memorize. And here they are. The sine of u plus v equals sine u times cosine v plus cosine u times the sine of v. So there is a pattern to this where you notice if this is sine u plus v, it's a plus sign. But it's going sine the first angle times cosine the second angle plus cosine the first angle sine the second. The only difference on the right column is the sign changes, that's it. So when I do cosine u plus v, it's cosine u times cosine v minus sine u times sine v. And then that's a plus. Tangent has a little pattern. Tangent u plus v is tangent u plus tangent v over 1 minus tangent u times tangent v.
No. They can hear you're just crazy.
Okay. So here, I believe that. Okay, so then the sign just changes. On Monday, we're going to have a memory quiz, and I'm going to show you the memory quiz. It's those 6. I'm giving you the left side, and you have to give me the right side. So Monday, this is the quiz. It's right here. I'm showing you. It's just that side. Not this side.
Not this time.
In example 1, it says find the exact value of cosine 75 degrees. Exact value means I'm not using my calculator. It's not a decimal approximation. 75 degrees is not a unit circle value. However, if you look at these sums and differences, can you think of a sum or difference of 2 unit circle values that would produce 75 degrees? Tyler?
45 and 30.
There we go. So we're going to do the cosine. 45 degrees plus 30 degrees. It would not matter if you put the 30 degrees first. We're still going to ultimately get the same answer. So you look at your cosine formula. It's the addition. So we're going to do cosine 45 times cosine 30. Now it's a minus sign in between. Sine 45 degrees, sine 30 degrees. And then it's a good thing we've been doing these over and over again, and we know these values. This is square root 2 over 2 times 1/2. Oops, nope, I just lied. That's radical 3 over 2, sorry. Minus, that's radical 2 over 2 times 1/2. So one answer is radical 6 minus radical 2 over 4. However, in the back of your textbook, they write it where they factor out the radical 2 over 2 and make it radical 3 minus 1. It doesn't, over 2, sorry. It doesn't matter. Do you see those are equivalent? So don't let it bother you. I think these are easier, radical 6 minus radical 2 over 4 versus this, but they write it that way. It's kind of weird. All right, let's look at example 2. It says find the exact value of sine pi over 12. Now this is in radians, and I want you to see if you can do some kind of addition or subtraction. And I'll tell you it needs to be subtraction. It's a unit circle subtraction that produces pi over 12. Can anybody think of 2 unit circle values that subtract, John?
Pi over 3 minus pi over 4.
Good job. That's pi over 3 minus pi over 4. Now you should have been thinking 3 and 4 have a common denominator of 12. Now if you think of 6 and 2, 6 and 2 don't have a common denominator of 12. They have a common denominator of 6. 2 and 6. So earlier they wanted to do 2 and 6. If this is kind kind of blowing your mind, you're thinking, how do you know that? Well, if you get a common denominator, that really is pi over 12. So just remember that now. A pi over 3 and a pi over 4 will subtract to give you something over 12. Okay? So now, according to the sine formula, this is sine pi over 3 cosine pi over 4. Now the sine formula is the same sign, so it's a minus, but then it goes cosine pi over 3 sine pi over 4. Now plug in your unit circle values and see if you can simplify it. Again, I am going to finish this lesson today, but tomorrow I have some classwork you're going to do to just let this sink in and gel. So this is radical 3 over 2 times radical 2 over 2 minus 1/2 times radical 2 over 2. That's radical 6 minus radical 2 over 4. That will be a common answer, okay, very common answer. Example 3 says find the exact value of sine 42 degrees cosine 12 degrees minus cosine 42 degrees sine 12 degrees. So what you want to do is you want to look back at your 6 formulas. You know it can't be the tangent because there's no tangent. And then when you're trying to decide between sine and cosine, the cosines are cosine, cosine, sine, sine. So you know it's not cosine. So this is actually the sine formula. And because it's a subtraction, it's the sine of 42 degrees minus 12 degrees, which is the sine of 30 degrees, which is 1/2. Does that make sense? All right, then let's look at example 4. It says write cosine, the quantity arctan 1 plus arc cosine x as an algebraic expression. So what I'm going to do is I'm going to look at arctan 1 as being equal to u, and arc cosine x is v. So then I actually have the cosine of u plus v. So anytime that it seems like it's a little bit too difficult, we can always do substitutions. Well, if I have cosine of u plus v, I now know from my formula list that that's cosine u cosine v minus sine u sine v. All right, well this is the cosine of whatever u is, and u is arctan 1. Cosine of v is cosine of arc cosine x minus the sine of u is the sine of arctan 1, and then the sine of v is the sine of arc cosine x. Kind of scrunching there. Now this is not an algebraic expression. An algebraic expression does not, trigonometric expressions are called transcendental functions. Algebraic functions have x squared, okay, square root of x. But your logarithm, exponentials like e to the x, and trigonometric expressions are referred to as transcendental. They're not algebraic, okay? So I'm trying to put this in some kind of algebraic form. That means I don't have any sine, cosine, arctan, or cosine. So I'm going to look at this piece that says u is arctan 1. Well, if I remember this from chapter 4, when I have inverse trig functions or arc tangent, this really means the tangent of angle u is equal to 1. All right? So let's draw a triangle here. We'll put u down, and if tangent of u is 1, that means it was SOHCAHTOA, 1 over 1. And I can find the missing side by Pythagorean theorem, so that's radical 2. And then if v equals arc cosine x, This means the cosine of v is x. So we'll put a v here, and cosine is x. That really means, oops, putting that in the wrong spot. Cosine SOHCAHTOA is adjacent over hypotenuse, so this is x over 1. By the Pythagorean theorem, that's the square root of 1 minus x squared. So remember, okay, this is very, very abstract, okay, we're going up there. So look, arctan 1 is u. So I really want to look at this row right here, okay? These two are equivalent with my substitution. So cosine of u would be 1 over radical 2, or radical 2 over 2. I have cosine of v. Cosine of v is x over 1, or just x. Minus, then I want the sine of u. Sine of u is 1 over radical 2, or radical 2 over 2. And this one's the sine of v, which is radical 1 minus x squared over 1. Okay, let me pause here a moment so you can sort of look at this and think about it. Because then once you do, it's like, oh, that's not as bad as we thought. Okay, let's go back through it. Cosine of u. You come to the u triangle. Cosine of u is 1 over radical 2. That's where radical 2 over 2 comes from. Cosine of v. I come to v, that's x over 1. Minus, this is the sine of u. That's 1 over radical 2, which I know is radical 2 over 2. Sine v is radical 1 minus x squared over 1. Does everybody see that? All right, now, it does make a little bit more sense to factor out the radical 2 over 2's. And then we're not going to do any other simplifying. That's it. Okay? All right, example 5 says prove the cofunction identity cosine pi over 2 minus x equals sine x. So I've been waiting and waiting to be able to show you this because we looked at graphs, we looked at numerical examples, but we really weren't proving that this was true. Now, with our sum and difference formulas, we can actually prove that cofunctions are in fact complementary. On the left side, if I use my cosine formula for a difference, it's going to be cosine pi over 2 times cosine x. Now cosines have the opposite signs. And then it goes sine pi over 2 times the sine of x. Do you guys see how I expanded that? Something else I want to point out, because I know you guys have been trying to create new properties that don't work, and I'm afraid somebody's going to do this. Cosine of pi over 2 minus x is not cosine pi over 2 minus cosine x. You see that on the front page? That's not true. But I'm afraid somebody's going to try to say, oh, I'm going to make a new property here, and that's not one that works. All right, cosine pi over 2 is 0. Sine pi over 2 is 1. So this is 0 plus sine x. So now what's neat is when you were verifying identities, we can now open a whole new area to be able to verify with sum and difference formulas. Okay? So you guys see, we just proved then that that's why the cofunctions work. That is pretty awesome. All right, sum and difference formulas can be used to derive what we call reduction formulas. And what that means, essentially, is that you're, sometimes adding a 2 pi or adding 5 pi over 2 or something like that where you're going more than once around. So look at example 6 with me. It says we want to simplify letter A, cosine the quantity theta minus 3 pi over 2. So according to the formula, that's cosine theta times cosine 3 pi over 2. Cosine's the opposite sign, so it's a plus. And I do sine theta times sine 3 pi over 2. So that's cosine theta times 0 plus sine theta times negative 1. This is 0 minus sine theta. So what's interesting is that the cosine of theta minus 3 pi over 2 is actually equivalent to negative sine theta. Okay? All right, letter B, tangent. We haven't done tangent yet. And I do need to caution you as you start tonight's homework in the book. You're going to plug it in, and then you're going to look in the back of the book, and you're going to be confused with how they got their answer. So I want to try to help you with that frustration. What they're doing is you end up with a complex fraction in a lot of them, and you have to get a common denominator up here, common denominator down here, multiply by the reciprocal, but then you're going to be left with radicals in the denominator, and you have to rationalize. So it's a lot of simplifying. And I'll be happy to work some of those out for you. But just know that when you get to the tangent ones. All right, here we go. Tangent is tangent theta plus tangent 3 pi over 1 minus tangent theta times tangent 3 pi. So I'm going to give you a moment so you can think about your unit circle values and how you figure that out. Alright, are you getting tangent theta? Tangent 3 theta is 0. Tangent 3 theta is the same as tangent theta. So that's 0 over negative 1, which is 0. And I hope you understand, that's why I've been trying to take you away from that unit circle sheet of paper, that you've got to be able to mentally think, okay, where is that sine over cosine, 0 over negative 1, and work, because now that's very, very secondary in what we're doing. All right, we're going to skip example 7 and we're going to jump to example 8. It says find all solutions of sine of the quantity x plus pi over 4 plus sine of x minus pi over 4 equals negative 1. So what we're going to do is we're going to expand each of these using our sum and difference formulas. So this goes sine x cosine pi over 4 plus cosine x sine pi over 4. Okay, that's the first one. Plus sine x cosine pi over 4 minus cosine x sine pi over 4 equals negative 1. Do you see how I just expanded it? Now we can do some canceling, right? My cosine x sine pi over 4 cancels, and then I have like terms. This is 2 sine x cosine pi over 4 equals negative 1. Okay, I have 2 of those. Now we know the cosine of pi over 4. What is the cosine of pi over 4? Radical 2 over 2. The 2's cancel, right? And then we get radical 2 sine x equals negative 1. If you divide by radical 2, you get sine x equals negative radical 2 over 2. What's theta prime? Pi over 4. So sine is negative in what 2 quadrants? Third and fourth. So this is 5 pi over 4 and 7 pi over 4. Now a question I've gotten the last 3 days that we've worked on solving equations is, how do you know when you do plus 2 pi n, how do you know if it's plus pi n or pi over 2n? What do you notice about these two? You what?
You're not gonna be able to have two pots.
They're all
You're
the
not.
same.
Yeah, if you think about where they are, I like the hand motion there. Okay, to go from the third to the fourth, that's 90 degrees, but I can't add another 90. That doesn't put me back in the third quadrant. So my solutions are 5 pi over 4 plus 2 pi n, where n is an integer, and 7 pi over 4 plus 2 pi n, where n is an integer. So now we've taken what we can verify and expanded what we can do with it, and now we've taken our equation solving skills and expanding that. That's really neat that we can do that.